Hey everybody, welcome back. We are to chapter 8, where we only have a few sections to do. This first one is important, and we run into quite a few different word problems as we do this. We're doing systems of linear equations, and there are two main methods that we use. These are what are called 2x2s, meaning there are two equations with two unknowns. We'll be doing 3x3s today. That's actually page 2, so we'll be doing some of those. But there are three general ways. Two methods that we use with 2x2s, and that's substitution or elimination. There are actually dozens of different methods depending on the size of them. They can get up to be like 1,000 equations by 1,000 unknowns, and there's reasons for that. There are three ways that we're going to get an answer. One of them, and the most common one, is that we get one unique solution. So for example, 1, 2, meaning x equals 1, y equals 2. And in general, what we have when we have 2x2s like this are two lines crossing each other. And the one solution is that one point that is on both the one line and the other line at the same time. Otherwise, another possibility is that there's no solutions. And what that looks like is that you have two lines that are parallel, meaning they're never going to cross one another ever. The third option is when they're dependent. And what that means is the one line is actually the other line just rewritten. So they're actually the two of the same line. So there's an infinite number of solutions there. And that's what we call dependent. So let's start with part A. And for part A, I'm going to use the elimination method. And I'm going to eliminate the y variables by multiplying the top equation by a 4. And what that's going to do is that's going to make a negative 4y and a positive 4y. So when I add the two equations, they eliminate the unknown variable. So this becomes 8x minus 4y equals 12. That's that top equation multiplied through by 4. And then we have 5x plus 4y equals 40. And very nicely, when I add these two equations together, 8x plus 5y is 13x. And you can see we've eliminated the y's, negative 4y plus 4y, they're gone. The elimination method is sometimes referred to as the addition method as well, depending on the textbook. And many books call them both, actually. And this becomes 52. And now when I divide by 13, x equals 4. Now, that's only half the answer. I now need to figure out what y is. And I can actually plug the x into the top equation or into the bottom equation. It won't matter. I'm going to get the same y regardless. I'm going to plug it into the top one here. You can even put it into a modified one, just as long as you're sure that you did it correctly. This becomes 8 minus y, so I'm going to subtract 8 minus 8. So negative y equals negative 5, which means y equals 5. So my answer is 4, 5. So this is an example of one solution. So if I were to graph these two lines, I would see them cross at the point 4, 5. Part B, I'm going to actually take this top equation and subtract the 3x. So I get y equals 10 minus 3x. And I'm going to use this was using the elimination method or the addition method. This one, I'm going to use the substitution method. And I'm going to take this y value, y equals all of that, and I'm going to put that right into there. So this becomes 9x plus 3 times 10 minus 3x equals 13. Distribute and combine. And notice what happens here. 9x minus 9x, x's are gone. And we end up with a statement with no variables at all. And what this means for us is that, by the way, this is a false statement. 30 does not equal 13. These are two different values. And so this is the case where there is no solution. Sometimes we use the null set. circle with a line through it. And this means that they are inconsistent. And what it really means is that the lines are parallel. So they're never crossing each other. So I've used the elimination method. I've used the substitution method. And it doesn't matter what method you use, you should come up with the same result. So if I chose to do the second one using the elimination method again, maybe multiply the top one through by -3, it would still be inconsistent. It would still be parallel lines. All right, for this next one, I'm going to subtract a 2y to the other side. I'm going to use this substitution method again. So x equals 4 minus 2y. And now I'm going to take this. I'm going to plug that into there. So I get 7 parentheses 4 minus 2y plus 14y equals 28. I'm going to distribute. And -14y plus 14y, again, all of the variables cancel out. But the difference is this was a false statement. This is a true statement. This is our third scenario here where they are dependent. And the way we're going to write our answer is I'm actually going to take this equation and make that the way to write my answer. And you can see they've given us sort of a guide how to do that. So it's all x's and y's as long as x is equal to 4 minus 2y. And y is any real number. By the way, you could have solved for y and said that x is any real number. So it really doesn't matter. And it should specify for you. All right, let's move on to 3x3 systems. So part A, let's start here. A 3x3 system, we tend to use more the elimination method. A more advanced way of doing this would be putting them all into matrix form and then solving them using matrix form. We're not going to go through that in this particular video. I am going to notice that if I take, let me number these a little bit. I'll call this 1, 2, and 3. If I take row 2 and add it to row 3, I'm going to eliminate one of the variables. So the goal here is to eliminate the same variable 2 times. So I'm going to go row 2 plus row 3. That's 2x plus y plus z equals 3 and -2x. So I'm eliminating the x's. Let's write that. You can eliminate the x's, y's, or z's. It doesn't matter. It looked easier to eliminate the x's in this case. And that's plus 3y minus 3z equals -17. That results in, the x's have been eliminated. This gives me 4y. This gives me minus 2z. And that looks like -14. So there's one of my eliminations of x's. I now need to eliminate the x's again. I'm now going to go 2 times row 1 plus row 3. So if I multiply that by 2 and add it there, do you see I'm going to eliminate the x's again? So 2 times row 1 is going to look like this. 2x minus 6y plus 8z equals 38. 19 times 2 is 38. I'm going to add that to row 3, which is -2x plus 3y minus 3z equals -17. And again, the x's eliminate. I'm left with -3y plus 5z equals, let's see what that is, 38 minus 17 is 21. So what I've done is I now have 2 equations with 2 unknowns. So I've gone from 3 equations with 3 unknowns down to 2 equations with 2 unknowns. All right, so now I have a 2 by 2, and it does look like, and I have my two methods of solving that. That could be a substitution or elimination. I'm going to do elimination, and I'm going to multiply I'm going to choose to eliminate the y's, and I'm going to multiply the top one by 3 and the bottom one by 4. And what that's going to do is that's going to change that to a 12 and that to a negative 12 in front. Then I can eliminate them. So 12y plus 6z equals 3 times 14 is 42. 3 times 14, yeah, negative 42. This one is going to be negative 12y plus 20z equals 4 times 21 is 84. So looks like I get 26z equals, I don't know what that is. Actually, I do, that's 42. Something has gone awry here. Let's double check our work here. Okay, we're good here. Right, this actually should be a minus, is the problem. Minus, which turns that into 14. 14z equals 42. That's going to be better. 42 divided by 14. Whoop, 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 whoop. 42 divided by 14. Better. So it looks like z is 3. I'm now going to go back to my 2 by 2 and finish solving it. So I'm going to go 4y minus 2 times 3 equals negative 14. 4y minus 6 equals negative 14. Adding a 6 to both sides, 4y equals negative 8, y equals negative 2. So I have z, I have y, now I need x. So I want to go back to any of my original, I'll go back to this one here. Push that up a little bit. So I'm going to use row 1 here. So x minus 3 times negative 2 plus 4 times 3 equals 19. So x plus 6 plus 12 equals 19. X plus 18 equals 19. Looks like x equals 1. So these are actually geometrically, these are planes, like pieces of paper. And where do 3 pieces of paper cross? Well, they're going to cross at this specific point. So this is going to be 1, negative 2, 3. So you can see we get a point that all 3 of these planes are crossing through. Again, that's one of our, let me pull this back up for us. One of our possibilities is that we get one unique solution. And that's exactly what we have here. Let's go to part B. And for part B, what I'm going to do is I'm going to, again, label these 1, 2, and 3, rows 1, 2, and 3. And it looks like I can, so many possibilities. Let's multiply, I'm going to eliminate the y's in this case. So I'm going to go here. Let's do 4 times row 1 plus row 2. And what that'll do, that'll make that a negative 4 and a positive 4. So 4 times row 1 is going to be 4x minus 4y minus 4z equals 16. And then 3x plus 4y plus z equals 4. Let's see what happens here. So we get 7x minus 3z equals 20. So let's eliminate the y's again. And I'm going to go get low on space here. How are we doing on the camera? Let's scooch that up. So I'm going to, let's do, to eliminate the y's, I'm going to multiply row 1 times 9, and and add that to row 3. So 9x minus 9y minus 9z equals 36. Row 3 gives me 12x plus 9y and plus 0z. I'm going to sneak that in there. Equals 0. Let's see what we get. It looks like we have 21x minus 9z equals 36. And my 2 equations and 2 unknowns now, and I can actually divide this through by 3. And I notice this becomes 7x minus 3z equals 12. Do you see that I have, that's this one here, and then this one here is 7x minus 3z equals 20. Now, that is a problem. Let's subtract these, and we'll notice that we get 0 equals -8. So this is what we, again, we say there's no solution. Yeah, too low, no solution. And we say that they are inconsistent. So no solution, inconsistent. All right, let's sneak C here. So for C, again, I'm going to label these row 1, 2, and 3. And I'm going to eliminate the x's, we'll say. So I'm going to go, let's do the y's again. It's going to be easier. I'm going to go 2 times row 1. So row 1 times 2 plus row 2. So 2x minus 2y minus 2z equals 2. And then -x plus 2y, so the y's are going to eliminate there, minus 3z equals -3. And that gives us x minus 5z equals -1. So let's eliminate the y's again. And I'm going to multiply -3 times row 1 plus row 3. Row 3. So looks like we get x, the y's are gone, -5z equals -1. Ooh, look at that. The same equation. So this is, we can write it like this. The answer is all real numbers. And we can get fancy and just put the all real number symbol if you want to. So here are the 3 cases again. We have one unique solution. We have no solutions, or we have all real solution. Any real number is a solution. Let's do some applications here. All right, so these are all 2x2 systems. There are applications with 3x3 or even larger, but we're not going to do that in this video. The admission fee at an amusement park is $20 for children and $35 for adults. On a certain day, 291 people entered the park, and the admission fees collected totaled $7,845. How many children and how many adults were admitted? Let's start here. Let X equal number of children. Y equal the number of adults. And we know that X plus Y equals a total of 291 people. So this has to do with people. The next equation is going to have to do with money. So it's going to be $20 times the number of children plus $35 times the number of adults totaling a total of $7,845. Now, it looks to me like we can divide that 5 out of the second one here. Let's make these numbers a little nicer. That'll be 4x plus 7y equals 7,845 divided by 5, 1,569. And I'm going to rewrite this one. I'm going to do substitution method, and I'm going to write that y equals 291 minus x. So all they do is subtract an x to both sides. And I'm going to substitute this now into here. Let's do the distributive property. 7 times 291. Combining up my like terms, I get negative 3x plus 2037 equals 1569. Subtracting the, so 1569 minus 2037, so negative 3x equals negative 468. That by negative 3. That. So x is 156 children, which means if I go back to here, y equals 291 minus 156. 291 minus 156 is $135. Not so bad. To me, the setup is where it gets a little tricky. All right, next example. 4 large cheeseburgers, 3 chocolate shakes cost a total of $7. Wow, that's really cheap. 3 shakes cost 50 cents more than 1 cheeseburger. What is the cost of a cheeseburger? All right, so let's, and how much is a shake? So let x equal the cost of cheeseburger. And y is going to be the cost of a shake. And let's do the money first. So we know that 4 large cheeseburgers, 4 cheeseburgers, and 3 chocolate shakes cost $7. And we know that 3 shakes cost 50 cents more than a cheeseburger. So I'm seeing 3y is equal to x plus 50 cents. Actually, this one's kind of cool because we have 3y and 3y. So we actually can just replace the 3y, the whole thing, with that. So 4x plus x plus 50 cents equals 7. Kind of cool. So that's 5x, and subtract the 0.5, so that's 6.5. 6.5 divided by 5 is $1.30. Is how much a cheeseburger costs. Well, that's a cheap cheeseburger. So now what we can do is we can plug this into here. This is the cost of a cheeseburger. So now let's do 3y equals $1.30 plus 0.5. That gives me 1.8. 1.8 divided by 3. How much is the shake? 60 cents. This is not a modern day meal. All right, last one. A man has 25 coins in his pocket, all of which are dimes and quarters. And if you're not familiar, dimes are 10 cents, quarters are 25 cents. If the total value of his change is $4.30, how many dimes and quarters does he have? Let's start here. Let X equal the number of dimes, Y equal the number of quarters. And it looks like we have a total of X plus Y equals 25 coins total. So this is coins, pieces of metal. And the next one's going to be money. So a dime is 10 cents. A quarter is 25 cents. And that's going to total $4.30. Once again, I'm going to do substitution method and rewrite this. Y equals 25 minus X. And plug it into there. If you want to multiply through by like 100 to get rid of the decimals, you could, but because we have calculators, there's always no need to do that. All right, 0.25 times 25, 6.25. Combining up my like terms, so 0.1 minus 0.25, negative 0.15x, and I'm going to go 4.3 minus, I'm going to subtract that, 4.3 minus 6.25. Divide that by negative 0.15. X equals 13 dimes. Because X is the number of dimes, meaning Y is 25 minus 13, 12. So 13 dimes, 12 quarters. Not too bad, just need to be a little patient.